There are so many different types of attacks that go after the second layer of the OSI model, and we need to be aware of them for the Security Plus exam. If you're not so familiar with them, well, you're in luck because that's what we're talking about coming up next.
You're watching IT Pro TV.
Welcome back to Security Plus here at IT Pro TV, and today's episode is all about Layer 2 attacks. And if you're not familiarized with Layer 2, don't worry, we're going to get to that in just a moment. But Wes, why don't we just out of the gate kind of give the people out there that have tuned in a sneak preview of what's to come in this episode. What kind of attacks against Layer 2 are we going to be looking at?
Absolutely. Let's go ahead and do that. So we've got the attacks here up on our screen. We're going to be looking at these three different attacks. We're going to be looking at something known as the ARP poisoning attack. That's address resolution protocol, as well as MAC cloning and MAC flooding. And we are talking about media access control addresses, not message authentication code. So let's go ahead and get those acronyms that we just threw at you straightened out right now.
Important clarifications here
That's
at
right.
IT Pro TV, trying to keep you good folks squared away. Now that we understand what we're going to be looking at as far as attack-wise, I think it would probably benefit us if we started off with reminding ourselves why we call this Layer 2 and taking a look at something like the ARP process before we get knee-deep in these attack types.
Hey, sounds good. So let's go ahead and let's take our minds back to the theoretical Network Plus days. And if you're not familiar with this, that's okay. That's why we're putting it in this show. But I encourage you to be familiar with the model that Dan just mentioned, the Open Systems Interconnection model. So if you're not, let's go ahead without further ado. Let's dive right in. So we have this 7-layer model. If you say top to bottom, you're going from application to the physical. If you say bottom to top, you're going from physical to the application
I
layer.
thought it was beans, then guacamole, cheese.
It depends
right?
on how you
Oh,
stack it.
yeah.
I mean, it is a layered approach, right?
That's amazing. Bring your tortillas.
Absolutely hungry here. So if we look at the layers, right, they're layer 7 starting at the top to layer 1 going down to the bottom here to the physical layer. Now, let's take a look at what is happening real briefly. Just if this is new to you, I definitely encourage you. It's kind of a little bit of a prerequisite knowledge for taking the Security Plus exam, but it might be a refresher for some of you too. Remember that when we talk about the application layer, we're talking about this is the layer that gives our applications our first bit of entrance or access to network-based resources. The presentation layer generically is kind of like the syntax layer, right? It formats our data in a way that's standard so that the network doesn't even have to worry about how's it formatted. Is that encryption I see there? Is that a GIF or GIF, however you say that? Is that a PNG file? We don't care about that. And we certainly don't want the network to have to worry about it. Then we have the session layer, and the session layer, if you will, is out there for opening, closing, and maintaining. Tearing down is the closing part of these communications. We also have the transport layer that sometimes is called the host-to-host communication layer. And remember that the transport layer is responsible for actually delivering our information. This is where we say, do we want a connection-based protocol, connection-oriented protocol like transmission control protocol, TCP, or maybe connection list like UDP. And if we choose TCP, that's where the segmentation and the sequencing happen. Down at the network layer, addressing and routing, and more specifically IP addressing, right? That is it is important to understand that because we also have some addressing that happens at the data link layer, which is layer 2. Layer 2 is responsible for our LAN communications. The network layer is actually what allows us to communicate really across the internet. If it wasn't for the networking layer, you wouldn't be able to connect to some remote network halfway across the world. Data link layer, this is where we're actually within our local area network here. We're using things like our MAC address, if you will, that unique address that identifies the network adapter and by association the computer that it's installed on. And our switches, if you will, use this information to forward traffic between ports. And you know what I didn't mention, Dan, let me take a second here. Networking layer, remember that's where we have things like our routers. Our routers do the routing, they make the routing complex decisions. Data link layer, that's where our switches work. Next is our physical layer. And our physical layer really defines the electrical communications and the media type that we're going to use. This is where we say, hey, yeah, it's Ethernet. Ethernet, by the way, also operates at data link layer because it works on MAC addresses, but it also works at the physical layer too because it says, all right, well, we're going to use twisted pair copper media. Or maybe we're not. Maybe we're not going to use that. Maybe we're going to use fiber optical media, right? Or maybe we're going to use radiated energy and do a wireless communication. So that's what we're seeing here in the physical layer. Now, When we talk about layer 2 attacks, understand that what we're talking about is down here at the bottom, data link layer. Now you might be asking yourself, well, Wes, you just said this is a layer 2 attack. Why do you got layer 3 up there? Well, that's because if we look at layer 2 and layer 3, you have to understand that layer 3 is where our IP address is. The logical addressing happens. And make sure I said that right, layer 3. Layer 2 is where the MAC address is. This is a burned-in physical address to the network adapter minus virtualization technologies, and it can become software-based. But this is what is identified at the data link layer. These two, they don't understand. They're completely oblivious of each other. All right, so what sits in between these two layers is this protocol known as the Address Resolution Protocol, or ARP, like we've mentioned. All right. So how does this process work? Well, because the network layer, IP, knows nothing about a MAC address, when that traffic finally gets across the remote networks and gets to the LAN that's the destination LAN where it needs to be delivered, if we left it up to IP would say, hey, I did my job. I don't know where else it's going, right? So that's where ARP comes in. And what ARP does is it says, I will help IP map this IP, if you will, address to the data link layer-based MAC address. So what it does is it sends out a broadcast communication to the local broadcast address on that network. And it says to everybody, hey, who has 10.10.10.10? Now, you can have, I just put 3 computers on here, but every computer that's within that broadcast domain, they can hear that broadcast traffic. All right, is going to hear that, but only the computer that actually has that IP address is going to respond back to ARP. It's going to actually tell you, guess what? I know where 10.10.10 is. That's my MAC address. Go ahead and why don't you just tell ARP that that's where you can find that IP address. Tell them that it's at this MAC address, and then what the computer does is it caches that in the local ARP cache. Now, just like in DNS, we want you to keep in mind that when we need to finally talk to the computer that has that IP address, we don't need to send an ARP broadcast anymore. We can just send that communication based on what we have in the cache right directly to that computer. So it makes it very easy to find that computer and not have to go through the ARP process again.
Awesome. I assume that we do this because, well, we typically use IP addresses and computers don't mind using the MAC addresses. So it probably makes it a little simpler for us as humans to say, hey, I'm just looking for 10.10.10.10, not D5C, 6, and so on and so forth. That's a little clumsy for us. So the computers use ARP very well, and we use IP a little more frequently than we do ARP, or not ARP, but layer 2 addressing. Just makes our life a little bit easier. But with that ease, right, as we saw Wes kind of tee up for us, we do have some attacks that can go against that thing. Because a lot of times that's what's going on, right? Wes is, we make these systems and they're kind of complicated. So we've got to like simplify them to make our lives a little bit easier, managerially, administratively. But that's when attacks can come into play, especially one just like ARP poisoning.
That's right. So think about if you've come maybe to this episode from our DNS attacks, you're probably aware of the DNS poisoning. Really, ladies and gentlemen, this is it's almost like the same thing, but now we're talking about that ARP poisoning. All right, so here's what happens this time. Now we've got our source computer, and it's going to say, hey, I need to find, oh, and by the way, understand that a router can do this, but a lot of times on your local computer, or on your local networks, if the computer that I'm looking for is local, then I don't need to send any traffic to the router. The source computer can do this itself. It's going to say to the local broadcast, hey, who's got that address we just talked about? But here we go with our well-groomed hoodie-based threat actor. Says, you know what? If I can get that information, if I can respond back to you before the legitimate computer ever says anything, then what's going to happen is that's going to get stored in that ARP cache. And wait for it, you've guessed it, now it's poison. So that the next time, keep in mind that the source computer needs to send traffic to that MAC address based on that IP address. It's not going to call back out to ARP. It's just going to say, let me look at my local cache here. And you know what? I'll pull that answer out of the local cache. And now what's happening is the attacker is redirecting traffic to their computer. And then from there, well, they can basically do what they want with the traffic.
Gotta love it when they do that, right?
That's right.
That's exactly what we're trying to avoid. Now, this is accomplished because most systems are set up to dynamically update those caches. So an attacker will take advantage of that fact, saying, "Oh, you'll just accept anything I throw at you? Great! Here comes some wrong information."
That's right.
You're gonna enjoy. Well, I'm gonna enjoy it. You probably won't, but as an attacker, I would. Now that moves us on to the idea of MAC cloning, right?
Sure.
Because just because this is an actual physical burned in a MAC address onto these interfaces doesn't mean we can't tell the system that, hey, I'm that guy. That's who you're looking for. It's me. We can actually clone and spoof the MAC address to different devices, correct?
Yeah, and you know, Dan, some people might, I know I was kind of interested in this when I first started learning about it. I'm like, what do you mean people can spoof MAC addresses and clone MAC addresses? They're hardware-based addresses that are burnt into the network adapter. They can't be changed. Wrong. Well, that's because every single time you use something like virtualization, you're using some kind of spoofed or cloned, if you will, not even really cloned because they have to be unique, a spoofed MAC address. And what do I mean by that? You have one physical, let's say, server. It has a single network adapter, or maybe even two network adapters. It's multi-home, but you're running 15 machines, virtual machines, on that one virtualization platform. How is it that each one of those 15 machines have their own virtualized network adapter and can communicate? Well, that's because the hypervisor is actually doing the spoofing of the MAC address. It's generating virtualized MAC addresses for every unique instance of the machine running on itself. And those machines still have to abide by the rules of TCP/IP and the OSI, no different than any other device that's physically attached to the network. So understand that the ability to create a MAC address, it's a legitimate process. But remember, like we've said here, and in any security training, you'll be familiar with the fact that anything that can be done for legitimate systems administrative purposes can also be exploited by the bad actors as well. So let's go ahead and let's talk a little bit about MAC cloning. Again, very simplistic process, and the fact that, remember that your MAC address in your operating system, it's not inspecting the physical adapter. That's the drivers communicating with the operating system, and then the operating system controls the TCP/IP stack and communicates. So if we can manipulate that representation in software, then it doesn't matter what the physical address says on the network adapter, because the operating system is going to be none the wiser, and neither are the systems that you send information to. So we've got a network adapter and we've got a MAC address. Remember, 6-byte address, 3 bytes is the vendor ID, OUI as they call it. The other 3 bytes uniquely identifies that network adapter, right? A little bit of the what the MAC address is. And when we need to send information across the LAN between two computers, now we are going to be sending it through a switch, but even the switch, remember, is using the MAC address to determine which ports to send the information out. Now, here's where the attack happens, right? Same thing, no different, but now we've got the well-groomed bad actor sitting in between, and what they do is they run something like, let's say, MAC Changer, I believe in Kali, and they spoof the MAC address, right? Now they make the MAC address look like it's their legitimate MAC address, and that takes the legitimate computer out of the communication, and now the attacker can control the communication between really any device that's going to send information to what the other MAC address, the legitimate MAC address, was supposed to be. Again, a way to redirect the information to the bad actor's computer.
Now, those dirty threat actors, their fun is not just confined to the end systems themselves. Sometimes they can actually play around with the networking hardware that is moving this data back and forth between these systems.
Sure.
And even exploit them on a layer 2 level. Is that correct? And this is something that we call like MAC flooding.
MAC flooding, that's right. So let's go ahead and set up this attack. So we've got our switch, all right? And our switch, legitimate process, right? What happens,
It's a
right?
nice switch, by the way.
What's it? You like that switch? Yeah, I like the color too. So the switch, the computer sends information. All right, remember what a switch does. It forwards information between two ports, and how it makes that decision is when information is sent into the switch, it inspects the source MAC address. And if it's the first time the computer's communicated with a switch, it usually does a little bit of negotiation and says, hey, here's my MAC address, and the switch puts it right in its MAC table. All right, now when it needs to make a decision where to send that destination traffic, it builds up the MAC table based on the computers that are connected to its ports, and it forwards the traffic to the appropriate destination port. Now, let's set up our attack here. We've got our switch, we've got our MAC table, but now we've got our bad actor. our bad actor starts flooding this switch with a bunch of bogus MAC addresses. All right, well, what's going to happen to the switch? The switch, if it doesn't have certain protections like DHCP snooping, dynamic ARP inspection, port security, I think Dan was one that mentioned it in an earlier episode where you only have static mappings of your MAC addresses, it's going to start filling up this table with these bogus MAC addresses. And then once that small finite table gets full, what's going to happen? Well, it can't store any MAC addresses, so what the switch is going to do is a process called failed open. Now, what does that mean? That is technical jargon for the switch turning itself into a hub. Hubs are layer 1 devices. Remember, they only send electrical communications. They don't inspect any of the traffic, and they flood information with broadcast communications out all their ports. Well, in a security context, broadcast communications are very dangerous. If everybody can hear everybody, that means if your bad actor's on that network scraping some of that information through a sniffer, he can or she can capture that information and then store it and use it later. And that's where the problem comes with MAC flooding. We've got to be careful with that, and that's definitely a layer 2 attack you want to be aware of on the exam.
Awesome stuff. Well, there you go with layer 2, giving us a great idea of the different attacks and everything. I know, Wes, you got a little bit of show and tell for us. Kind of give us a peek under the hood of some layer 2 activities, so that we can just be a little more familiarized and have our hands dirty with it a little bit. So, what have you got for us today?
Most definitely. So, I'm actually in Wireshark here, and what I'd like to do, first of all, I'm going to show you the local ARP cache on this Windows machine. So let me go ahead and do that. I'll fire up our command prompt here, and let's do that. And let me give a little bit more real estate on the screen here. If we run an ARP-A, you can see that this is the ARP cache for each one of the interfaces that this machine is connected to, and this is where it's pulling that information off of the local network and storing it locally. And then after it has this entry in the ARP cache, remember, it doesn't use ARP to resolve that name anymore, or that IP address to its MAC address, and it pulls it from here. And if the attacker can get that bad information in this ARP cache, remember, my computer isn't going to use the ARP process anymore. It's going to look locally, and it's going to respond for better or worse.
And we see that with that type says dynamic right there. That lets you know that it was learned dynamically. Wes didn't go in and say, this is the MAC address for 192.168.0.100. It learned that through that ARP process.
Most definitely. I'm glad you pointed that out too, because the statically mapped ones here are the ones that are directly related to the TCP IP configurations of your network adapter, and you might recognize some of these IP addresses. Remember I told you it sends to the local broadcast address? How does it know that? Well, when you configure the TCP IP properties of your network adapter and set the subnet mask, it automatically knows that 255 are all ones in the host portions, the broadcast address, so it statically maps it. 192.168.0.255. All these other ones, those are the multicast addresses, right? And everybody uses multicast addresses, so these don't change, and that's why you see static entries versus the dynamic ones that you see Dan mentioned here. One last thing I'd like to show you, I mentioned Wireshark. I told you about packet capture. If I fire up something like Wireshark, I just wanted to kind of show you that quite legitimately, ARP is asking these questions. So before I actually fire up the packet capture utility, I'm going to do a ping, and I'm just going to pick a bogus address, if you will, that's not really being used at all, transparency on my network at all that I've got this computer connected to. You're going to see it's not going to resolve. But that doesn't matter, because it doesn't have this IP address in the local ARP cache. Let's go ahead and fire up Wireshark, and let's see what's going on here in the background. One of the things you're going to see here is that we got a lot of ARP traffic going on. Notice the destination tells us it's the local broadcast address. And notice what it's saying. Who has the address I'm pinging? Tell my computer, which is 192.168.0.10. Tell them. And it keeps finding it. It keeps telling ARP. ARP's not actually going to find a reply back. But let's say, and if it does, Dan's probably attacking my network. The point being here is you can kind of see that ARP process. And if the attacker can exploit this ARP process, get that information in the cache, the traffic can be redirected to the that computer at the attacker's will.
Yeah, it's great stuff. And it is very dangerous for our environment, so we got to be prepared for those layer 2 types of attacks. And remember, we took a look at the old OSI model, a little refresher on that, and the ARP process. Then we walked through a couple of attacks like ARP poisoning, as well as, what did we look at? MAC cloning and
MAC
black flooding attacks.
That's right.
I can't remember these things. So much in this episode crammed
We
in.
call that brain flooding.
That's exactly what it is. But great stuff. Well, good job, Wes. We appreciate it.
Yeah.
We appreciate you watching. More to come in Security Plus, but we are out of time for this episode. So we're going to call it ace, and we'll see you guys next time.
Thank you for watching IT Pro TV.